Given that ASP.NET MVC is a model view controller framework, and we've already seen what it can do for views and for controllers, you might be wondering what it does for models. Well, I'll tell you what it doesn't do. It doesn't force you to implement your models in any particular way. It doesn't require you to inherit them from a certain base class, and it doesn't try to enforce any opinions about how you should do data access. The idea is that you're in control of these, and you can use any technique that's available in the entire .NET ecosystem. Instead, ASP.NET MVC gives you a powerful set of conventions-based mechanisms to help you describe the meaning of your models to the framework so that it can help you generate user interfaces, parse any incoming data onto your custom model objects, and also validate any incoming data according to your model rules. In this episode, we'll start by looking at the metadata system, which underpins many of the other systems by providing a means to describe what kinds of data your model can hold. To refresh your memory, here's the application that we created previously in the episodes about controllers. Users can search for job ads, and when they do that, they might be given a spelling suggestion, and they can follow that, and once they've spelled things correctly, they might well get back a list of job ads that match their search term. What we're going to do during the next few episodes is create an administrative interface so site administrators can come along and post new job ads into the system. To get started with doing that, I'm going to create a new controller called admin controller. And my admin controller right now only needs one action. I'll call it create, and it will return the view, which will be the data entry screen. But I want to set up an initial state on that screen, so I'll say initial state is a new job ad, and by default we'll say that its publishing date is today, and I'll pass that to the view. So I should be able to run that action by visiting admin/create. Of course, I haven't created a view for that just yet, so I'll do that now. I'll say add view, and all of those settings are good. So I'll just tidy this up very slightly. And now I've tidied that up, I'm going to create a HTML form into which the administrator can enter the details of the new job. I'll have a submit button, and I'll just run that now to check that it's all working. Okay, very good. Now, in the episode about views, which talked about scaffolding, you will have seen a HTML helper method called editor for model. I'm not going to explain in detail now how that works because it was covered in the other episode, but if I run my application with an editor for model, we'll see that we get a scaffolded user interface. So the framework has looked at my model object, iterated through all the properties, and generated a suitable editor control for each one. And if I was extremely lazy, I could say, well, my job is done, I've created my user interface now. But I think most users would think that that's not a very attractive user interface, and there's some quite weird things about it, such as why it's asking the user for job ad ID. What is the user going to enter there? They probably have no idea. And salary 0.00, it's unclear what that means. Is that per week? Is it in dollars or pounds or what? So I'm going to use some metadata now to change the way that my scaffolded user interface appears. I'm going to add metadata by using some attributes that are in an assembly called system.componentModel.dataAnnotations. And also there's one in System Web MVC that I'm going to use, so I'll reference those. And now on my job ad model object, I can declare an attribute such as hidden input to say that the unique ID should be a hidden field and not actually displayed to the user. I could also use the display name attribute and say that instead of simply saying the word salary, I want to display the caption annual salary in dollars. So with these metadata attributes in place, if I reload, we'll see that the job ad ID has been hidden now, and the salary caption has been changed to something a bit more useful. And this is the whole idea of metadata. Because .NET model classes on their own don't describe very much about the meaning of the data they hold, we can use attributes or other sources of metadata to provide additional information that will influence the way that our screens appear and work. And I could go on adding more metadata attributes to this class, but let's say that I don't actually want to put my metadata directly onto my job ad model class itself, perhaps because this class is normally generated by a linked SQL designer or something like that, or maybe I want to move my metadata into a whole different class library project. Well, if I don't want my metadata on the model class itself, I can create another class called a buddy class and tell the framework to fetch the metadata from there instead. So I'll create a new class called job_add_metadata, and I'll surround it with a partial class called job_add. and this partial class name has to match the name of my model class. And then on that I use a special metadata attribute called metadata type to tell it which other class is acting as the source of metadata. Now I know all this metadata type and partial classes seems a bit strange, but it's a fairly simple pattern once you get used to it. It doesn't really get any more complicated than you can see on the screen right now. So all I have to do now is go back to my real model class, declare that to be partial to satisfy the compiler, and then I'll just copy all the properties from my real job_add class and put them into job_add metadata. And just to be clear, this class is not used except as a source of metadata, so it's completely meaningless for any of these properties to have behavior. So I'll just replace them all with these simple auto properties since they'll never actually be used anyway. And now the framework will take its metadata from this buddy class. And now hopefully I can remove the metadata attributes from my real model class, reducing it back to what it was before. And we'll hope that the metadata will come from the buddy class. I'll verify that by recompiling and reloading. And we can see that it is still displaying this caption, which is now coming from the buddy class. Okay, now the user interface is still looking pretty rough, to be honest. I'm going to try and make it better by using more metadata attributes. There's a few things I want to fix right now. Firstly, this caption is very strange and I'll have to give it a more human readable caption than that. Secondly, I don't want to accept hours, minutes or seconds in the publish from date. I just want to accept a date. And thirdly, I don't really want administrators to be entering anything for the more details PDF file name. So I want to just remove that from the scaffolded user interface altogether. So again, I'll use the display name attribute to change the label associated with this property. And yet again for publish from date. And I'll say that the data type for this field, even though it's a date time, I just want to treat it as a date and we'll ignore the time part of that field. And finally for the PDF file name, I'm just going to say don't scaffold that field at all because I don't want the administrator to be able to edit it directly. I'll give it a recompile and then reload. And we're kind of getting somewhere now. It's looking slightly more respectable as a user interface. Now let's have a look at the HTML that's coming out of this scaffolder. What we can see is that the framework is producing appropriate CSS classes that surround each one of the input controls and divs that it generates. So I'm going to be able to use some CSS to improve the appearance of the user interface a little bit more. I'll go into my site's CSS file and down at the bottom I'll simply paste in some CSS that I prepared before. We won't really worry about how that works because it's just CSS. And now if I reload, we'll see it's again looking a bit better. Now I don't really like this checkbox because I find it quite hard to understand. The user has got to read this caption and then try and figure out what checked means and what unchecked means. It would be much easier to use if it was radio buttons instead. Now I can use metadata to tell the framework to use a custom template to render an editor for any given field on my model. And during the episodes about views and partials you'll already have seen an example of how to do this. So I won't explain that all over again, I'll just go through this fairly quickly. I'll create a new folder for my editor template. And in here I create a new partial view. So I say it's a partial view and I'll call it job_add visibility options. And this is going to be an editor for a property of type bool. First I'll just check that we can render this template. On my metadata, I'll use a metadata attribute called UIHint. And I'll say that this field's editor is the template we just created. I'll try that, reload, and we can see that the checkbox has been replaced with our custom template. So I'll go back in here and I'll put the radio buttons. Firstly, a radio button for if the model value is false. So this radio button will start checked if the model, which is the property in question, is false. And that means that the visibility is not restricted, so it's visible to everyone. And then I'll have another radio button for if the model is true. and that starts checked if the model, which is the property itself, is true, and that means that visibility is restricted only to members. Right, let's have a look at these radio buttons. There we go. I think that makes the user interface easier to understand, except I can improve the caption very slightly. Try that. There we go. That's quite a nice user interface. In fact, we could argue that this user interface is perfect. After all, we were able to use metadata and custom CSS rules to control its appearance, and how could it possibly be any better than that? Well, that's the sort of misconception that only a programmer could have, because when we show this to the graphic designer on our team, then I can guarantee that they'll say, "That's disgusting, what on earth is that? That's not how our user interfaces look. This is exactly why we don't let programmers design user interfaces." And you'll say, "What's wrong with it? What do you actually want?" And at this point, they'll probably send you a Photoshop file, or if you're very lucky, they might send you an HTML mockup of the thing they actually want. So let's imagine in this example that we've got a very generous graphic designer who's going to provide us with a HTML mockup. So I'll paste the mockup into my view and we'll see what it looks like. I'll just run that now. And we can see, well, yeah, I suppose maybe they had a point. Maybe that does have slightly more flair than the scaffolded user interface we had before. And I guess we have to admit that for certain types of application where design aesthetics are even slightly important, we can't get away with fully scaffolded user interfaces. So what we'll do now is go through this simple HTML template that we've been provided and replace all of the static input fields with text box and editor templates so that our model values get displayed properly. In this case, we want a text box for the job ad's title. And we have to preserve these CSS classes that we've been given. So I will specify that the field should be rendered with this class attribute. We don't need that anymore. And then in all the other cases, I can just use the editor for helper so that it displays text boxes and also respects any metadata attributes that we might have defined. And again for the publish from. And finally again for the visible to. So if I rerun now, we've got the model data back. One thing we've lost in the process, however, is the hidden field which specifies the job ad ID, so I'll just stick that back in. And there we go. If you see in this user interface now, we are back to displaying the salary as a decimal, and the date as just a date without a time, and our custom template. So that shows how we can take an arbitrary HTML template and combine it with the templated input helpers to mix the benefits of scaffolding and metadata in with the benefits of having total control over the HTML. Our user interface is now finished, but this episode is all about how to use model metadata, and I want to show a few more ways that we can use it to establish conventions that apply across our entire application. First, let's go back to look at the metadata itself. Some of this we just don't need anymore, such as this, and also these display names since they're now specified in the view. And I don't need to say anything about columns that aren't even referenced in the view. That simplified things slightly. But what about this? Having to explicitly state that this is a date. You could argue that it's kind of obvious really, given that it's of type datetime and its name specifies that it's date. Well, surely it's obvious that it's a date. Can't we just have a convention that automatically works this out instead of having to be told? Well, yes, we can set up that convention using a custom metadata provider. To make sure we can see this working, I'm first going to delete this metadata attribute, and I'll show you that when we rerun the application, the publish from has now reverted to show a complete date time, including a time, which is the thing that we don't really want. I'll fix this by creating a custom metadata provider class. I'll add a new class to the utils folder. And since in aspmvc you can only have one metadata provider active at any given time, I'm going to retain all the behavior of the existing data annotations metadata provider by inheriting my new class from it. And all I have to do is override a single method, create metadata, and I'll take the metadata object that the base class creates and capture that in a local variable and initially just return that. So I haven't changed the behavior at all yet, but now I can enforce my new convention. And my new convention is, if the model type is datetime, and remember in this case the model is just the individual property, so if we've got a property of type datetime, and if the property name ends with date, then the new convention kicks in, and that is that when we're editing this property, we're going to use the following format string. And so that's just a date with no time part. Okay, so I'll compile and rerun the application. And what we observe is that it makes no difference whatsoever. And the reason for that is that we haven't yet told aspmvc to use the new metadata provider. It's very easy to do that though. I'll just go into my global.asax file and say that model metadata providers.current, that's the single current metadata provider, will be an instance of the metadata provider class we just created. So this time, if I reload and watch the published from field, we'll see that it's changed to reflect the new edit format that we've defined. So now we've got the convention that the editors for all properties of type datetime, whose name ends with date, should just be date. Well, that was pretty simple. Let's do something a little bit more interesting. We might expect that we'll frequently need to create these lists of radio buttons throughout the application. And if we go back and look at the metadata, we see that we achieve that by using a UI hint in a custom template. And we might feel that we don't want to have to keep creating these custom templates all the time, but we'd rather generate a list of radio buttons purely using metadata. Let's create some custom metadata that can do that. I'll start by making a new attribute called option. I'll put it in a folder called metadata. So it's a regular C# class called option attribute, and it doesn't know anything about data annotations or aspmvc. It's just an attribute. I'll let it store the display text for the option. So that will be the caption that appears on the screen, and we'll also store the value that it corresponds to. So now back in my metadata, I could say that for this particular property, I want to have an option that applies when the value is true, and that should display with the caption members only, and another option for if the value is false, and that displays with the value everyone. And I'll get rid of this UI hint attribute because we just want to use that as our metadata. So if I compile, right now we'll get a compile error because I've tried to use the option attribute twice, and that's not allowed by default on new attributes unless you specifically tell the compiler that you want to allow that. So I'll go back to option attribute and use the attribute usage attribute to say that this can be used on properties, and we allow multiple of them on a single property. And a similar but slightly quirkier issue is that aspmvc gets a list of custom attributes using a .NET component called type descriptor. And when type descriptor builds up a list of your attributes, it stores them in a dictionary. And the way it generates the keys that goes into its internal dictionary means that if you have multiple attributes of the same type, then they overwrite each other, which kind of messes things up. So we have to override a method called typeID to give it a unique key for each item. And the easiest way of doing that is just to use the actual attribute instance as the key in the dictionary, so that each instance can be stored separately. Now, if I compile and reload, we'll observe that nothing useful happens other than that the framework has reverted back to showing a checkbox because we've removed the UI hint that told it to render a custom template. So now I'll update the metadata provider so that it recognizes our custom option attributes and does something useful with them. Inside the metadata provider, I'll try and get a list of all the option attributes. So that's all of the attributes that are of type option attribute. And if there are any of those, then I need to store them in the metadata. And I can store them in a dictionary called additional values, which is a place that you can store your own arbitrary custom metadata. And I'll put that in under the key option values. And the thing that I'll assign to that will be all of the option attributes converted to a dictionary, where the key in the dictionary will be the unique value that the option takes, and I'll store that alongside the display text. And because we've detected at least one attribute, I'll say that we're then going to render a custom template, and the template will be the job ad visibility template that we created earlier. So I'll go back to this template and just put something else in it. And if I compile and reload, we'll see that the option attributes have triggered the use of the custom template. So now in the custom template I want to actually render these radio buttons. So I'll pull them back out from the additional values dictionary, and then I can iterate over these. Of course I have to cast this to a dictionary, otherwise it will just be an object. And now for each one I'll render a radio button. The radio button will refer to the value of this particular option, and the radio button should start checked when that particular key equals the current value of the model. And of course the text we want to render is the display text, which is what we stored in the value in the dictionary. And finally, let's just make sure that each one appears on its own line. Now if I reload, we'll see that these options have come back, except this time they didn't come from a custom template, they came from metadata. And this custom template now could be renamed, so instead of being job ad visibility options, it could be something like radio buttons, because it's now totally general purpose. And we are able to define arbitrary collections of radio buttons that will appear in the view simply by using our custom option attributes and our custom metadata provider. So that is how we can combine templated view helpers and custom metadata to generate arbitrary user interfaces from convention, while still having absolute control over the HTML structure in the view. That's enough about metadata. In the next episode, we'll think about what happens if the user clicks Save on this screen, and talk about how to use the model binding system to parse the incoming data back onto custom model objects.